Today we will discuss lecture 7, where we will be discussing programming or middle layer design and construction. So this middle layer design and construction is a big topic, and I will divide it into at least three lectures. So today we will discuss about introduction of middle layer design, then design and implementation software engineering methodologies, procedural programming, a brief introduction, object-oriented programming, basics of programming languages, variables and variable types, operators, decision trees and loops, and methods. So from classes and objects onwards, I will cover in next lectures. Essentially, the software programming, which is commonly known to most people, is done to build the middle layer. Most of the work involved here. The other part is the designing the user interfaces and designing and constructing the databases. But most of the work is in programming is done in building the middle layer or the business, implementing the business logic. This is because, uh, in spite of all the automation done in many areas, in many industries, programming is one area which still involves manual working, like programmers will be writing source code. So far, no uh, no no system has been developed which could create source code automatically. In some areas, some development has been done in creating source code automatically, but most of the time it has to be done by programmers manually. So let us start uh, this session. Uh, First of all, why we need to do programming? This is because the computer can understand only machine code. It cannot understand any other language. Like human beings can understand natural languages like English or Hindi or any European language or any language. Means if they they have been brought up in an area where some language is prevalent, so they are exposed to that language and they understand and they use that language from early in their lives. But computers understand only machine code. And machine, what is the machine code? It is a code which is in binary fashion, like it will be consisting of only zero and ones, like switch on, switch off. So uh, composing this 0101 in many, like 0001 0 11 1 0, they mean different things, and computer understands it very well. So to when we create a software product, we basically essentially when it runs on the computer will be seeing only these zeros and ones, and then it will do its processing, and it will provide some output given on some input. So uh, this is all the computer can do. But to let uh, the computer program to let the computer like giving the instruction to the computer, how you are going to give the instruction. Like if you write a program with zeros and ones, it will be huge, like it will be very difficult for a human being to write all that. So what is done is that some programming languages have been devised. So these are very near to our natural language like English, and then we have compilers or interpreters. So we give this computer program to a compiler. The compiler will compile or save and then convert this code, which is very near to natural human language, to machine code, and then the computer will understand. So this is how it works, and this is why we need to write source code in using any of the programming languages, so that we can write some computer programs. Software products are pieces of machine codes which a computer can understand. Human beings cannot understand this machine code. Software engineers use programming languages to write source code. This source code, when compiled, get converted into machine code. Software requirements are written using a natural language which human beings understand without any problems. A software product needs to be developed based on these software requirements. A software design needs to be developed based on these software requirements. Later source code needs to be written based on this software design. When this source code is compiled, then the source code is converted into machine code. This machine code is the software product. Now, one thing about computers is that the computers which have been developed, uh, basically, they are the machine, they understand the machine code which is of two types. Uh, I guess I'm forgetting the name. I think it is long Indian and short Indian, something like this. So, uh, like one form of machine code, uh, computers understand which when it is written from left to right, and another form it is right to left, something like that. So they are basically two types. So when you compile a software program on a computer, then suppose the computer understands only the machine code which starts from left to right, so it will convert that program into this machine code which is from left to right. But if another computer which has an operating system which works differently, like it reads from right to left, so in that case, this compiled program, like this machine code, cannot be run on that computer. So you need to again write a software program uh, which may be compatible with that computer or operating system. So this is a big task for a software vendor to write too many programs for different kind of platforms or software computers or operating systems. So over time, something has been devised which is known as bytecode. So some programming languages in what they do is they have interpreters. So when you write a source code in one of these programming languages, it will be interpreted into bytecode. So a bytecode is an intermediate uh, code, and this intermediate code is then is then fed to a runtime environment, and this environment will then convert this bytecode into machine code, and only then the computer can understand. So here the runtime environment is different for different operating systems, so that the bytecode will be the same, but the runtime environment will convert that bytecode into appropriate machine code. So suppose we have Apple operating system and Windows operating system. So when we created a program in a programming language, say Java. So when we this source code we bring to say Apple computer. So there, on the Apple computer, there will be a runtime environment, Java runtime environment for Apple, and it will take this bytecode of your computer program, and then it will convert into a machine code which can be understood by the Apple operating system. Similarly, this same program can be taken to a Windows operating system, and there the runtime environment is for Windows, and the same bytecode it will take and then convert into a machine code which is compatible with Windows operating system. So this means you don't need to write a software program for different kind of operating system. You just write once and can run on any computer. So one aspect of this bytecode is this explanation, and it is very useful. Nowadays, most of the programming is done using one of these languages, which have this facility to interpret into a bytecode and then convert into a machine code. When a piece of source code is compiled to create machine code, this machine code is platform dependent. This generated machine code can run only on computers which run the same operating system as the one on which the machine code was generated. On other operating system, this machine code will not run at all. In this scenario, the software project team may need to write source code separately for each operating system on which the software product is targeted to run on. The source code written for a specific operating system uses specific operating system dependent functions. Thus, the source code will be written differently for different operating systems. This is a lot of work for the software project team. Platform independent programming languages like Java, C hash, etc. have evolved to solve this problem. For these programming languages, there is a compiler or interpreter which converts the source code into what is known as bytecode. This bytecode is platform independent and can run on just any operating system. A virtual machine is the runtime environment. A virtual machine converts this bytecode into machine code. A virtual machine is a language specific runtime environment which converts bytecodes into machine code. The most basic elements of any programming language are variables, methods, operators, decision trees, etc. A variable is a placeholder to hold a piece of data which can be manipulated to do various kinds of computations. So now we are coming to know about programming languages, the basic idea. So the most elementary thing in any programming language is variables. So variables are a placeholder to hold a piece of data, and this can be manipulated to do various kind of computations. Most computations involve numbers, characters, yes, no decisions, etc. To take care of these kinds of computations, various types of variables have been defined in programming languages. Essentially, they are data types of variables. For example, in Java, there are variable types as int for integer type variables, char for character variable types, boolean for boolean decision types, float for decimal fraction variable types, etc. Now let us see a small program to understand variables. So here I have provided a very small program, and this program is written in a pseudocode. So here what this program will do is it will do multiplication. So we can create a variable, say a, and then we can create a variable, say b. Now in this variable a, say we are assigning 5. Here you see the equal sign. It is not the equal sign in programming languages. In programming languages, the equal sign is used for assignment. So a equal to 5, which is written over here, in programming languages it is a assignment 5, means assign a value of 5 to variable a. Then we have 6 assigned to variable b, and now we need to do computation of a multiplied by b. So uh, this work, if you want to write in a programming language, so you assign, you do some like a multiplied by b, and you assign it into a variable, and then display that variable on user screen. So this kind of programming work is done in most of the programming languages. Only thing is the language syntax may be different for each programming language, but the basic work is the same. This program will first create two variables. Some numerical values are later assigned to these two variables. These two variables are then multiplied, and the program asks the computer to display the result of this multiplication on the computer screen. Now, let us come to a very important discussion about object-oriented programming and procedural programming languages. Because we will be learning both for the discussions, as well as even in the case study. I will show you how a software product is made, and we will be using both. So if you know some procedural programming language, you will know that in a procedural programming language you will have methods and variables, and you do not have any other scope apart from this aspect. Like where you can have methods, they will always be public because there are no containers outside a method. And then inside method you can have public as well as private variables. The public variables are the ones which are visible even outside a method. So you need these public variables because you need to communicate many things among methods, and you need to pass values from one to change to first to read, and then maybe to change the value of a variable. So in that case, you will need public variable, and private variables you will need use. These private variables are visible only inside a method. So these private variables are used to do computations for that method, and since they should not be visible, so that is why visible outside this method. That is why we create them as private. But when you come to class, so in class is a container for methods and even class variables. So in this diagram, you see we have a method one. Inside this method one, we have variable one and variable two. Now here, inside a method, you always create private variables because you do not need to create a public variable inside a method. If you need to create a public method, then you will be uh, creating that variable at the class level, not at the method level. So here we can see is two more variables have been defined at the class level, variable 1 and variable 2. One is private, one is public. So if you are creating a private variable at the class level, so it is visible at the class level, inside the class, but not outside. To actually, there is a mechanism to make them visible outside using get and set methods. So we will discuss them later when we discuss classes. Currently, I am only showing you this private variable. And of course, public variables, you can define the class level, and these variables will be visible outside this class in other classes, and you can pass. So, why we should have this private and public variable at class level, and what are the advantages and disadvantages? So, let us discuss this. Uh, when you define a public variable in a procedural programming in a method, this variable is visible everywhere in your software product, and anybody, uh, because on a software project, many people are software developers are working. So this variable, public variable, will be visible to all of them. And suppose in one of their methods they need this, so they will use this method, and by mistake they may also assign some other value to this variable. And in that case, what will happen is, since the value of this variable has changed without knowledge of other programmers, uh, it will give wrong results, because it will be used at many places by in many parts of the software product, and this will be a big software defect, because it will give wrong results. So public variables are a dangerous entity in programming. So in object oriented programming, this has been addressed by declaring private variables. So in your programming, you should never use public variables. You should only use private variables when you need to pass some value from one uh, class to another class, or one method to another method. So uh, this is the one of the great advantages of object-oriented programming over procedural programming. So we will discuss these things again when we move to class. So currently we will be seeing more about the programming language entities. Like we have seen the variables. Now we will see operators and method, different aspects of methods, how methods are made. Any variable can be defined as a private or a public type. A private variable can be visible and called only inside the programming structure within which it is defined. Public variables, on the other hand, are visible throughout the module in which it is defined. Variables used in a procedural programming language have a limitation of scope as compared to the ones used in object-oriented programming languages. In procedural programming, variables can only be defined inside a method. Variables which are to be used only for that method are declared as private variables. But variables which need to be used outside that method need to be declared as public. Declaring a variable as public poses serious problems. A public variable can be seen and accessed from any module of a software product. A public variable thus can be used and even reassigned some other value than a value it was assigned previously. This leads to software defects which are difficult to trace and fix. Variables used in an object-oriented programming language do not have this limitation of scope. A variable in an object-oriented programming language can be defined inside a method and also inside a class, but outside any method. A variable, when defined at class level, can be visible outside that class and can be accessed if declared public. But all variables which are defined inside a method are always private. Now, coming to operators, operators are like the assignment operator we had seen in the previous example. So, operators are used in programming languages to do many types of computation. Some of the operators include assignment, equality, less than, more than, count, etc. Assignment operator is used to assign some value to variables. Other operators are used to check conditions in decision trees, loops, and other programming constructs. So we will be seeing all these constructs later and some examples in programming also. So here you can see the if then and if then else decision trees. So in the if then tree, what happens is a software program starts and there you have some condition decision has to be made. So for example, if age of a person is below or above 30 years, so say if the age is below 30 years, you need to do some computation in that condition. So that means it is true, the condition is true. Then you need to you can do the you can perform the computation, and your operation will end. On the other hand, if not, if this condition is not met, like if the age is not below 30 years, but it is above 30 years, then what? So, to take that thing, we have if, then, else decision tree. So, in this kind of tree, one condition is will be true, another will be false. So in our example, like if the age is below 30 years, then the condition is true, then you do some computation. If it is false, that means the age is above 30 years. So you do some other kind of computation. So this is how the if then else and if then decisions are done in computing. Software programming is mostly about evaluation of some conditions. Based on evaluation results, some computing task is performed. Decision trees are one of the most commonly used programming constructs used in software programming. In a decision tree, a condition is evaluated. If the condition is found true, then some computing task is performed. If the condition is found to be incorrect, then some other computing task is performed. Now let us see one example here. You create a variable A, then you create another variable B, and then you create another variable C. Now you assign a value of 5 to variable A, then assign a value 6 to variable B, and then assign a variable C with value 34. Now you are checking if this variable C is greater than or equal to 30, then compute A multiplied by B, and then display this multiplication on user screen. If else, if this value C is not greater than or equal to, but instead it is less than 30, then display a message: age of the leader is below 30 and computation is not possible. So you can display this message in the other decision, like if this condition is false, if C is less than 30, then it will be the computer will compute this one, not the earlier decision. In the example, we can see that a condition, if C is greater than or equal to 30, then is tested. If the condition is true, then one set of computation will be done by this computer program. If this condition is not true, then another set of computation will be done. So it is if then else is a very commonly used programming construct in programming. Then another programming construct is while loop. So in the while loop, there will be looping operation done based on some condition which is met. So as long as the condition is true, the loop will go over and do some computation again and again till that condition is true. When that condition becomes false, then the program will terminate. So in the while loop, uh, if the condition is true, like suppose you are checking salaries of people, say five people, you are checking, and what you do, you count number of people. So you don't want to check salaries of more than five people. So you will put the condition like you create a variable, say I, and you increase this condition from 1 to 5. So in the first iteration, you check the salary of first person, and since I is at that time value of I is 1, and since it is and you set the condition, it should be less than say 6, so that it will compute only up to 5 people. So first time it will check salary of one person, and then this value of I will be changed from 1 to 2, because you will increment this value. And then again, since it will be less than 6, so again you will check salary of the second person. So you keep looping, and till the value of I becomes 5. The moment the value of I becomes 6, so that means this condition is no longer true. I is now more than 5, so it will terminate. So your program will terminate. Or you can also do like when this condition becomes false, you can do some other kind of computation as well. But again, you will need to keep checking, and then you need to exit the loop. Otherwise, sometimes we see endless loops. So that means the loop will keep running, and your program will never exit. And this is a kind of a software defect. Loops are another programming construct which are used to do computations based on evaluating some condition. As long as the condition holds true, some computation will be repeated. Once the condition turns out to be false, then the evaluation of the condition terminates. The execution then comes out of the loop and computation ends. One important aspect about loops is that in the condition statement, the condition should be incremented or decremented after execution of each loop. If this increment or decrement in the condition leads to a situation where the exit condition is never met, the condition is always true after a loop execution, then it will become an endless loop. This is a software defect that must be avoided. Now let us move over to methods. Now we have learned about variables, uh, operators, and programming constructs. So now let us think about methods. Methods in software programming are used for naming the wrapper of a piece of source code. So methods are a kind of wrapper. In procedure programming, a piece of source code is wrapped inside a method. When this piece of source code needs to be called from another method, then the method name along with the complete method signature is used. Since there is no wrapper above a method in procedure programming, a method is always public. Otherwise, it can never be called by another method. So, in procedure programming, methods are always public. In object-oriented programming, methods can be private or public, because in object-oriented programming, you have classes above method. So suppose a method is private. So in that case, this method is visible only inside that class, and it cannot be called outside this class. But if you define a method as public, then method can be called from outside of this class, from another part of your programming code. In object-oriented programming, a method is wrapped inside a class. When a method needs to be called from another method in another class, then the class name along with the method signature is used. A method in object-oriented programming can be both private or public. If a method is public, then it will be visible even outside the class in which it is defined. If the method is private, then it will be visible only to the methods which are defined inside the same class. So here is the method definition, how a method is defined. So one part of the method is modifier, and then data type, then method name, and then parameters, which the you can define some parameters for a method, and you can pass some values to this method. Then we have method body, and then you can have exception list. So if any exception happens during computation, then you can trap those exception, and you can do some error handling. And this is means the next is exception handling, where you do all the error handling. So these are all parts of a method. A method has a modifier which defines its scope, private or public. The data type declaration defines what kind of a value a method will be returning, an integer, string, boolean, etc. Sometimes a method will not be returning any value. So in that case, the data type will be void. It will not be returning any value. The method can have many parameters. Each parameter should be declared with its data type. Data is passed to a method through these parameters. The method body contains business logic which does some computation. The exception list contains exceptions which can arise during computation. These exceptions can be handled by writing exception handling logic. Now here is a diagram which shows how methods are called. Suppose we have a method A which parameters xy, and this method returns a value z. So it is called by a method B. So it will call method A with the values with parameters xy, and this method will return some value. It can be assigned in some variable, and method this value in stored in this method can be used inside method B. So this is how a method is called. Now here is an example of method being called from another method. We have a method called pass candies, and there are two parameters a and b. So here you can define also the data type of these parameters a and b, and inside this method you create a variable x, and then you assign variable x to a multiplied by b, and then this method will be returning value x. Now you have another method candy computation. So here you create a variable a, you create a variable b, you create variable c, you create a variable y, and then you assign a value of 5 to variable a, you assign 6 to variable b, you assign 35 to variable c, and then you are assigning the value returned by the previous method pass candies to the variable y, and here the parameters passed to this method pass candies, it will do some computation, and it will return some value, and it will be assigned to this variable y. And now you are doing the decision tree. So if c C, we have assigned a value of 35. If C is greater than or equal to 30, then display Y, display the value of Y. Or if C is less, then display some message to the user. In this example, a method is defined which takes two parameters. This method is called by another method with passing values stored into variables to the parameters of this method. This method does computations and returns the computed value. This value is then used in the other method. In object-oriented programming, there is a type of method which is known as constructor. A constructor has the same name as the name of its class. When the class is called without specifying a method name, then this constructor method is called by default. Constructors are used for following purposes. Identify the name of the objects that need to be created from classes. Object, that is object initialization. Then constructors are also used for method overloading. Then they are also used for copying or cloning an object. And then they are also used for assigning the value of one object to another. For example, we can initialize an object called person using the statement get set, and this object person. So this object person is of type get set, and you're creating a new object, new get set with some value. So say Natasha. So in this case, you initialize the object. When you create with the new keyword, you create a new object. So you create a object and you initialize with some value. So here you see this get set object. Actually, when you define a class which is named get set, and then you are creating an object based on this class, and you are passing some value. That means you are initializing this object with some value, like in this case Natasha. So how this is happening? Actually, basically, when we created the class with name getSet, we had a constructor or even a default constructor which will take the value, which will take the same name as the class, and you can pass some data there. In the O statement, the keyword new is used to create an object. GetSet is the name of the class. In many cases, if the constructor is not specifically defined inside the class, then when an object is created during runtime, a constructor is automatically created for that object. So this is how constructor is used. Now let us see a method overloading example. Actually, method overloading is what? Essentially, method overloading is used like you have the same method name, but with different parameters, and you define all these methods with same name, but with different signature like parameter or return type, and then you can call these methods differently, since they are defined differently. So to do some different kind of computation. So method overloading is used for this purpose, and the advantage of method overloading is that you are not creating many classes. In fact, you are creating only one class, and inside that you are creating different method with the same name, and you can use different method signatures to create different kind of objects from the same class. So that means there is a lot of code reuse going on. That means the same class is used to create different kind of objects, and you do not need to write different codes, different classes, different code for all these different objects. So this is the advantage. So here we have created a class rectangle with the private variables length, height, x and y. X and y could be like coordinates for the center of the rectangle to define the center of the rectangle. And then inside this class, we have created one method named rectangle. This rectangle will take the values this variable. We use the term this. This means in the same. We are in the same class, even though it's a different method, but the same class and some value like some variable like x. So here this means the x which is defined inside this class. So this dot x, and you are assigning some value 15. Then for variable y, you are defining some value 20. Then for length, you are defining some value 20. For height, you are defining some value 25. So in this method rectangle, you are defining these values. Now you create another method, same name rectangle, but a different method signature. Like it will take parameters. So this one is taking two parameters, length one and length height one, and then you assign this length one, which can be a coming assigned in a different from a different class, different method. When this method is called, some value will can be assigned from there. So that value coming, you assign into this dot length means this which we have defined here, length, the private integer length which we have defined in this class. So assign that the parameter value into this very local variable. Similarly for height, x and y. So you assign two parameters, and x and y you are again assigning locally. Then you can have one more method. Here now we have four parameters, means all the values to be set from outside when this method is called from outside. So through parameters, all these values of length, height, and coordinates for the center are assigned, and then the local variables are then initialized uh, based on these values coming through the parameters. So in the above example, method rectangle is overloaded many times with the new method signature. So the advantage is that you have you can create rectangles, in fact different kind of rectangles based on how some input can be done from outside. Many different types of objects can be created from the rectangle class. It is due to the fact that the rectangle method can be overloaded to produce these different objects. Like suppose we are creating rectangle 1 object. So using the new keyword, we are creating an object of rectangle type. So rectangle type we are creating to create object rectangle 1. And since here the method we are using, like in you can see previously we defined the method rectangle three in three ways. The first one, in the first one method, we have not passed any parameters. So when this rectangle one object is created, we have defined that it should be created based on this method, the first method. So it will take all the values which are defined inside that method itself. Like this rectangle will have uh, coordinates x15, y20, length 20, and height 25. And now when we if we create a new object rectangle 2 based on the other method which takes two parameters. So two parameters, the next one takes two parameters. It takes length and height, and it locally assigns values for coordinates x and y. So a new object will be object rectangle 2 will be created now, this time differently. So this time it will have a length of 30 and height of 35. So it is not the same. Earlier length was 20, height 25, but this time, since this value is coming from this assignment, so this rectangle will have different length and height compared to say rectangle 1. Similarly, rectangle 3, here we are assigning everything from here. When you are creating this object, we are initializing the length, height, and coordinates x and y. So we have created three objects differently, and they will be you can create these objects differently because we have overloaded the method rectangle when we created that class. When you test your code, you will see that three objects will be created. Rectangle 1 will be created with length 20 and height 25, and with the center with coordinates values 15 and 20. Rectangle 2 will be created with length 30, height 35, and with the center with coordinates 1 and 2. Rectangle 3 will be created with length 40, height 50, and center of the rectangle at coordinates 5 and 10. Method overloading is a good way to reuse source code. Just one method can be used to create many types of objects. One drawback of method overloading is that it leads to difficult to understand code. So one drawback uh, is that it will be difficult. Like the same method name is used to create different kind of objects. So there could be some confusion, like which object was created based on which method. But otherwise, code reuse is happening. You can see that we are not creating many classes to create these different kind of objects. Now I will show you the same thing in the example in an environment. Uh, on my computer, I have installed Eclipse, which is a Java and even other programming languages also, but mostly for Java. So uh, this rectangle example, we can see how it will work. So I have created a public class rectangle, same like I have shown over there, and I have defined the length, height, and coordinates, and then I have also defined actually the get and set methods. These methods actually we will learn more in later lectures. Essentially, like when I use a get method, what I am doing, I am reading the value of a variable, local variable. I have defined this class variables private. But if I want to see the value of this private variable, or to set, to change or assign value to this private class variable, then I need to use some kind of methods which are known as accessory methods, like a get method and set method. So I have defined get length method, and I am returning length. So returning length, this line length, this value length is the same as this private variable length. So from outside, if I say I get the value of local variable length, local class variable length, I will say rectangle dot get length. So it will give me this value stored in this local variable. So similarly, I have defined this get method for height. I have defined this get method for coordinate x. I have defined this value for this method, get method for coordinate y. And then I have defined all my three overloading classes, rectangle with the local assignment in the variables. Then the other method where some parameters, using some parameters, some value for length and height will be coming from outside. And then the third one where all the values for length, height, and coordinates will be coming from outside. So this is my class, and I will be creating some objects based on this class. So here I have created another class, test rect, and I will be creating objects. So one object I am creating, the first one, a rectangle one. So rectangle one is based on the first method, first overloaded method. Okay. Then I have created rectangle two based on the another method, and I am passing values here like 30 and 35 for length and height. Then the third object I am creating rectangle 3, and it is based on the third method, and where you can pass values for length, height, and coordinates as well. So, and then to show this, I can create a method. Basically, in Java, you can create method like public static void main, and there you can show, or you can print or do some kind of thing which makes actually this main keyword is used to show to the compiler that you can run this method, this class which has this method, and it can be run. Otherwise, other kind of methods can be called from some other method, and you means you cannot run from there. They are only can only run from some main method. So what I am doing in this, I am showing this value stored in this object rectangle 2, and this rectangle 2, I am passing the length and height as 30 and 35. So I want to get the height. Height is 35. So I want to get the height is stored inside this method. And this computation is done from where? It is this computation will be done from uh, this class and this method, the first method. Okay. No, sorry, the second one, because the first one is not taking in any parameter. This one, rectangle with two parameters. So length and height. So what I'm doing at the height and length, I'm passing from there 30 values with values 30 then 35. So they will be passed here, and then they will be stored in these local variables, and then they are uh, they can be assigned to objects. Like here, I am saying get the height of this object, and this object has been passed some values. So when I run, so when I run, you see here in the console it is showing value 35, and this 35 high, because it is coming from here, we pass this object this value. So you can check the other things also, like get length or coordinate x and y, because we have defined all of them. So like for rectangle 2 object, we are not passing x and y. Actually, x and y are stored here. Like x, the value of x is assigned 1 here. So if I write here rectangle to get say dot dot get x, suppose like I want to get, okay, so in x we have value 1, so it should show value 1. And now let us run. You see it is returning value 1 over here in the console. So this one is coming from the definition which we have defined here, x1, right? So this is how these method overloading works. So I'm ending this discussion here. We will meet to have further discussion on middle layer design and construction in the next lecture. So you can write me emails or tweet me if you have any queries. Thank you for your time. Bye.